In number 52, we are given a diagram with some angles marked and some lines labeled. And we are given 3 pieces of information. Each one of these is like a different problem. So in problem A, we are told that angle 1 and angle 2 are congruent. Angle 1 and angle 2 are congruent. And we're asked to decide which lines specifically can be proven parallel. So if angle 1 and angle 2 are congruent, they represent corresponding angles because they are both on top of a line on the left-hand side of this transversal. On top of a line on the left-hand side of the transversal. So that means that the lines that are parallel are the lines they sit on top of, so therefore we know that N is parallel to P. For problem B, we are told that angle 3 and angle 4 are congruent. So angle 3 and angle 4 are congruent. Angle 3 and angle 4 are in between these lines, L and M, and they both have something to do with the line N, which is like the transversal. So because they are congruent and they are inside these lines and on opposite sides of the transversal, they would be alternate interior angles. Because these alternate interior angles are congruent, line L and line M have to be parallel. Alright, finally, angle 4 and angle 5 are supplementary, which means that angle 4 plus angle 5 add up to 180 degrees. If angle 4 and angle 5 add up to 180 degrees, then lines L and M have to be parallel because they would represent same side interior angles. Alright, for number 53, we're asked to determine the number of lines of symmetry that each figure has. So I'm actually going to get out a shape for each one of these. Alright, for problem A, we're asked about a square. So we have to draw lines of symmetry that the square has. Because all of the sides are congruent, we can cut the sides in half and we can fold it over this line and it will match up perfectly. Also, because a square has congruent sides, we can also cut it down its diagonals. So in this case, we have 1, 2, 3, 4 lines of symmetry. In problem B, we're asked about a regular octagon. Regular octagon. Let's take this one. Alright. With the octagon, we can also go from vertex to vertex like we did with the square. So we can do that 1, 2, 3, 4 times. And because it's an octagon and there are an even number of sides, we can actually fold it in the middle of each one of these sides. So that would be 5, 6, 7, 8 times total. So the octagon has 8 lines of symmetry. Finally, a circle. If you imagine a circle, let's kind of get one out here to look at. Just have a circle. Honestly, here, anywhere that I try to draw a line of symmetry, I can do it, as long as I go through the middle. And it looks like we can pretty much keep drawing them all over the place, to a point where they're actually uncountable. So there's actually an infinite number of lines of symmetry for a circle. Sometimes we use the symbol infinity.